Namaste and welcome back to the data structures and algorithms classes. Guys, today the question that we are looking at is to find the prime factors of a given number. Now, factors by now everybody has understood clearly. What do you mean by prime factors? For example, 40. Now, 40's factors can be prime. For example, 2 into 2 into 2 into 5. Yes, definitely 2 into 2 into 2 into 5 is 40 and 2 is a prime number, 5 is a prime number. So don't you think the factors are prime factors? 27 is another example. Factors can be represented purely as prime numbers in the form of 3 into 3 into 3. Would you agree with me? 35 is 5 into 7, which means definitely every number can be represented as prime factors. I hope you're able to think. Of course, other than prime numbers themselves, because there, it will just be the number and 1 itself, but that's okay. All other numbers, all other composite numbers definitely can have prime factors. I hope you're able to think. Now that you guys understood this, now the next question is, how are we going to come up with this logic, right? See, first and foremost, one observation I want you to make so that you can keep it at the back of your mind. Let's take an example, 40, right? N is 40, let us assume. Now, what are the different combinations? Always, these factors or divisors appear in pairs. We have looked at it previously. 1, 42, 24, 10, 5, 8 are the different pairs that we have. However, please understand, just like this, if you think, there can be different combinations of prime factors, you are wrong. Why, sir, you may ask? Because please understand, prime factors are unique. They don't have you do not have different combinations of prime factors. What do you mean, you may ask? Very simple. See, that 1 and 40, that first case, it's not important to me because it's just like 40, right? 1 into 40 you are telling. So I'm just removing that. Now 2 into 20. Let's take 2 into 20. Now 2 is already a prime number. 20 can be written as 2 into 10, guys. Would you agree with me? 10 can be written as 2 into 5, which means it's 3 2's and 1 5. 3 2's and 1 5. Now that is the prime factor combination for this. Look at the next one, 4 into 10. Now 10 can be written as 2 into 5. 4 can be written as 2 into 2, which means again it is 3 2's and 1 5. 5 into 8, if you look at it, 5 is already a prime number. 8 can be written as 2 into 2 into 2. And if I just reorder it, again it is 3 2's and 1 5. So the first one, second one, third one, all of them, if in case you were to represent it using prime factors, is one and the same. Which means the first observation you must make is, you are only going to get a single combination of prime factors and your program should only be looking for that and nothing else. I hope you're able to think. Any confusion till this point of time? Great, sir. What else? What else means now it's time for our second observation. Time for the second observation. Now, on this side, I'm just listing all the prime numbers for you. So 2, 3, 5, 7, 11, 13, that. Now what you must understand is, let us take a number. For example, n is 900. Now what I will do is, I will take my first prime number and that 900 I will take and I will try to divide it by 2. Can 900 be divided by 2? Or in other words, is 2 a divisor of 900? I'm checking. Or is 2 a factor of 900? I'm checking. Definitely it is possible, it is divisible. So see, I'm putting that red color, or green color tick mark, telling you that yes, 100% it is divisible. Okay, it's divisible. Any confusion till here? Okay, great. What else? Now, obviously, if I divide 900 by 2, I will get 450, which means, would you agree that 900 can be written as 2 into 450? I'm starting to factorize it, right? Great. Now, see what I will do is, I will take 450 and I will check if it can be further divided by 2 itself. If I check if 450 can be further divided by 2, yes, it can be. Which means I will get 225. See, so I am putting that arrow. 225 is the result, which means I can write 2 into 225. I hope you're able to think. See, slowly factorization is happening. Again, I'll try to divide 225 by 2. But this time, 2 is not a divisor. It cannot perfectly divide. So I'm putting that X mark. Any confusion till here? Great, which means maximum with the prime number 2, these are the number of divisions that I can do, and you can see there are 2 2's, and even in the divisor you can see, even in the factorization bottom you can see there are 2 2's. I hope you're able to think. Great. Now I will proceed to the next prime number 3. So I'll take 225 and I will check if 3 is a divisor of 225. Yes, it is a divisor. 100% it is a divisor. So tick mark, and if I divide it I will get 75, which means I can write it as 2 into 2 into 3 into 75. Again now look at the pattern here. 75 I'll again try with 3 itself. I'll not change the prime number. Can 75 be divided by 3? Yes. What is the result? 25. Which means I can write this as 2 into 2 into 3 into 25. Next I'll check, can 25 be further divided by 3? Not possible, not possible. Only because it is not possible, then I will check with my next prime number, which is 5. Can 25 be divided by 5? Obviously. And hence, don't you think I can write this as 2 into 2 into 3 into 3 into 5? And 25 divided by 5 is 5. So one more 5 is remaining. And again, can 5 further divide it? Yes. 5 divided by 5 is 1. So there I will stop. I hope you're able to think. So look at it. Finally, it is 2 into 2 into 3 into 3 into 3 into 5. Which means 2 2's, 3 3's, 1 5. I hope you're able to think. Any confusion till this point of time? So very beautifully, if you take a number, keep dividing it by a prime number, and automatically how many ever times it can divide it perfectly, that many times the prime number will appear in the factors. And next take the prime number, again keep repeating it. How many ever times that next prime number can divide, that many times will appear in the factor. I hope you're able to see it. Beautifully it works. But now, yes, you understood this. But how are we going to write it as code, as logic, you may be wondering. Well, for that, let me change the picture a little bit and show it to you. Now guys, I want to show you something interesting about this logic. See, if you apply this logic, what will happen is, if you run a loop, automatically only the prime numbers will end up dividing this number. None of the composite numbers will divide this number. Oh really, sir? How will such a magic happen, you may ask? See, very simple. What I will do is, I'll run a loop where I starts from 2. Whether it is for loop or while loop, we will see later. I starts from 2. So I'm just marking 2 for you. I starts from 2. Now what happens is, let us assume our number n is 900. Okay. So what happens is, first time you will take 900, you will divide it by 2. Is it divisible? Yes. Which means n will from 900 become 450. N is changing. So see, I'm changing n there. N now becomes 450. Now 450, can it again be divided by 2? You're checking. Yes, it can be divided. It becomes 225. So see, n changes and becomes 225. Now if you check, can it be divided by 2? It is not possible. You cannot divide it by 2, right? So then you will stop. But now I'm asking, if you divided the initial value of n as many times as possible by 2, then tell me, will any of the multiples of 2 be able to divide that updated value of n, which is, look at this, all these are the multiples of 2. Can any value which is multiples of 2, can 4 divide 225, can 6 divide it, can 8 divide it, can 10 divide it, can 12, 14, 16, none of them can divide. Do you see how amazing this is? None of them can divide. Then what did you do? Now all you have to do is move I forward. Now I reaches 3. I'm just marking 3. So 225 can be divided by 3 once. You will get 75. N value gets updated. 75 can be again divided by 3. You will get 25. N value is updated. It becomes 25. Now 25 cannot be divided by 3. So you will stop, right? Now tell me, you divided the value of n by 3 as many times as possible. Now my question is, can any of the multiples of 3 divide it? Can any of the multiples of 3 divide it? Not possible. None of the multiples of 3 can divide it. So do you see, all this need not be checked at all? None of the multiples of 3 have to be checked whether it can perfectly divide that value of n or not, because n is getting updated. It's becoming smaller. I hope you're able to think. Beautiful. Now I value increments. It goes to 4. Can 4 divide 25? No. No means I value gets incremented, it goes to 5. Now 5 can divide 25. 5 can divide 25 once, it becomes 5. 5 can divide 5 once more, n becomes 1. Which means, can any of the multiples of 5, divide that value of n? No. We're able to think. And there we stop, because the moment n becomes 1, we stop. But you are seeing one amazing pattern here. Like this, like now next 7 if you take, right? If it was divisible by 7, then you will divide by 7 as many times as possible, which means none of the multiples of 7 can divide. If in case it was divisible by 11, once you keep dividing it by 11 as many times as possible, none of the multiples of 11 will be able to divide it. Similarly, if it was divisible by 13, you will divide, none of the multiples of 13 will be able to divide it further. So do you see a pattern? The only numbers which can divide it are the unmarked numbers, and all the unmarked numbers are primes. Which means the way we are writing the code is, we start with 2 and we start dividing it as much as possible. Then automatically, if you continue like this, only and only prime numbers will be the only numbers which will end up dividing your number perfectly, and only those will come as divisors, and only those will come as factors in your final answer. None of the composite numbers will come. So no need to check whether a number is prime or not before dividing it. You just run a loop from 2, right? Keep iterating the loop. The only numbers which will be able to divide it is nothing but your prime numbers. I hope you're able to think. Anyways, how will this algorithm look like in code? Let me show you. Watch and understand carefully. I have an n value which is 900, let us assume. Now how are we going to find all the prime factors of 900? Watch it. I'll go here, create a static function. I'll call it as prime factors. Okay, make fs capital. Yeah, and obviously this is going to take n as input. Inside this, what I'm going to do is, this is the core logic of the program. So bring the brackets down. So now in this part, I want you to understand what we are going to do is, we have n is equal to 900. Now visualize, what did I just explain to you? First thing that you must do is, you must start a loop where I begins from 2. The first number that you're going to start dividing it by is 2. So what I'll do is, I'll create one value I, I'll make it as 2. Int I equal to 2. I'll initialize it to 2. Great. And that is what I'm also just showing you there. I is 2. Okay. Now what happens is, what we have to do is very simple. We want to see whether this prime number can divide the given value of n. So say I'll tell n, or if in case n mod I is equal to 0. That is how you check if it is a divisor, right? If it is equal to 0, then what are we going to do? What we will do if in case it is equal to 0 is, then we know that I is a factor, and being a prime number, it is a prime factor. So you have to print it. So I'll tell system.out.println I will tell. However, right, what we have to do now is that we have to update the value of n, because you divided it, came as 0, but actually what according to our logic is, we took 900, we divided it by 2. So what we would have got is 450. Now that 450 should be the value of n next time. So see, 450 should be updated to n. How will we write that as code? I'll take n, I'll divide it by I, right? I'll get the quotient which is nothing but 450, update that to n. I'll update that to n. Now think about it. Now what must happen is, the next time, you should not now check with the next number. You have to check whether the same number 2 can again divide the value of n. Which means you should again take 450 divided by 2. Yes, it is divisible, and hence you have to again print 2, and that updated value 225 you have to store it in n. Then again you must check if 225 can be divided by 2. Because it is not divided by 2, only then should you move to the next number. Which means, would you agree this code should keep repeating as long as n can be perfectly divided by the current value of I in this case too. It should keep repeating. So what to do? What to do means, as long as this condition is true, it should keep repeating. As long as effect, if you want, always while loop is best. So remove that if, just remove if and make it as while. So what I have done, as long as n can be perfectly divided by the value of I, print that as a factor, update the value of n. Keep repeating, keep repeating. But at one point, for example, the moment n became 225, you could not divide it by 2 anymore, which means this condition will become false, you will come outside. Now the moment you come outside, now you must check with the next value. I should increment, I from 2 should become 3, which means I plus plus must happen. We're able to think. Then this same process should repeat for the next value of I. Then for the next value of I, then for the next value of I. Now this process must repeat till where is the question, look at it. N is 225, I is 3. 225 divided by 3 is 75. 75, so that is what is the updated value of n. 75 divided by 3 is 25. Updated value of n is 25. 25 cannot be divided by 3, which means I value will now increment, it should become 4. 4 cannot divide 25, which means I value will increment, it is now going to become 5. 5 can divide 25, so n will become 5 this time. Again 5 can be divided by 5, which means n is going to become 1. N is going to become 1. The moment n becomes 1, we must stop. So, for a particular value of I, check if it is a divisor, then print it, then update the value of n, again check if the updated value of n can be divided by the current value of I, keep performing this till it cannot divide it anymore, and then incrementing the value of I should keep happening till when? Till n value becomes 1. Don't you think that is our exit condition for the loop? Or one more way to say it is, as long as n value was greater than 1, perform this operation. Would you agree? That's what I am also going to do. I'll just go there and I will cut, you can just write while as long as n is greater than 1. I'll put the brackets, bracket always down, and I will put that there. I hope you're able to think. So see, this loop will keep, whatever is there inside this loop will keep working as long as n value is greater than 1. The moment it becomes equal to 1, it will stop. And in the process, you would have printed all the values of I, and you know it is only prime factors which will come, and that I have just previously explained to you. Will this work is the bigger question. Let's go and explore whether it will work, right? Watch it. So if in case I execute this, so obviously a void is the return type because we are printing it. I have to call it as well. So delete those extra lines, yeah. Fine. So remove that sysout statement, not required. Yeah, I'll just come here and I will just tell print prime factors, pass n, that's it, cool. I'll execute it. If I do so, and if in case I give 900 itself, which we just solved for, then clearly you can see 2, 2, 3, 3, 5, 5. 2 2s, 3 3s, 5 5. Perfectly, it works. Any confusion till this point of time? So I hope everybody understood this, right? So it works. Now, the next question is, hey, but does it really work? See, if this was a platform like LeetCode or HackerRank or HackerEarth or CodeChef, what would have happened is, the person who set this question would have created test cases. Test cases will be passed, right? Now, the number which I gave as input 900 is a composite number. But obviously, the person who set the question may also give prime number as input. He may give a prime number as input. See, I will execute it. If I execute it, then I'll give 13. If I give 13, you know 13 is a prime number. Prime numbers are only two factors, 1 and the number itself. 1 is neither prime nor composite, so it should not come in the output. Only 13 should come, which is exactly what will happen. So it works perfectly. Any confusion till here? However, now watch it. The time complexity is something you guys must be thinking about. Now, there's a very easy way to analyze the time complexity. I want all of you to focus, okay? let us assume guys that the n value, right, the n value happens to be some 40. N value is 40, okay. So if it is 40, there will be certain values of I and n. There will be certain values of I and n, right? I'm just showing you like this. Now watch it. First time, what is I value? I value happens to be 2. What is the n value? See, now 2 can divide 40 once, which means it will become 20. Then 2 can again divide 20 also, which means now n value will become 10. 2 can divide 5 also, 10 also, which means n value is going to become 5. So for 2, it is going to be 20, 10, 5. 5 cannot be divided by 2, so you will come out of the while loop, then you will tell I plus plus, which means I value will become 3. And because n is not yet 1, we will still continue. Now obviously, n is 5 here because 3 cannot divide it. Because 3 cannot divide it, you will come outside, you will tell I plus plus, it is going to become 4. N value is 5 only. Obviously 4 cannot divide it, which means you will come out and you will tell I plus plus, it is going to become 5. I hope you are able to think. And 5 can divide 5 one times, which means n value is going to become 1. I hope you are able to think. The moment it becomes 1, this condition fails, you will come out of the loop. So these are the total number of things. So you see total number of iterations, if you see 1, 2, 3, 4, 5, 6 iterations. 6 iterations. I hope you are able to think. For n value 40, my friends, it is 6 iterations for n value 40. However, I am saying, what if the n value was a prime number? This is a composite number. 6 iterations is not bad. But what if it was a prime number? I am just taking 13. If I take 13, then obviously all this is going to change. So I will just remove all this, right? All this will change. So now listen to me and listen to me carefully. First time I value is 2. N value is 13 only because 2 cannot divide it. This loop will not work. I plus plus 3. 3 also cannot divide 13, so it will be the same. This loop will never work. I plus plus. Can 4 divide? No. Can 5 divide? No. Can 6 divide? No. And how will they divide? I am asking. How will they divide? Because ultimately this is a prime number. It should not be dividing, right? Similarly, 7, can it divide? No. 8, can it divide? No. 9, can it divide? No. 10, can it divide? No. None of these guys can divide. I hope you're able to think. Similarly, can 11 divide? No. Can 12 divide? No. Can 13 divide? No. 13 can divide, which means obviously this is going to become 1. The moment it becomes 1, you will exit. So how many iterations? How are you able to think? Literally 13 iterations. Any confusion till this point of time? So obviously for a prime number is a worst case, worst nightmare for your program if n is a prime number, because this inner loop will never execute because no number will be able to perfectly divide it other than the number itself, which means till n becomes 1, if this outer loop has to keep working, then I value from 2, it has to become the n value, which is the prime number. So in a way n iterations it is taking, which means in worst case, big O of n. Big O of n means everybody knows this is how the graph is, linear. Not good for us, right? So how do we optimize this? How do we optimize this is the question. How to optimize? Let me show you. How to optimize this code is the bigger problem here. Very simple, guys. If you look at it carefully, here you look at this, such less iterations. Why such less iterations when n is equal to 40 is because number one, 40 is a composite number. And if you look at it, this n value is changing for every value of I. What is changing this n value is this inner loop. Because I is able to divide n, this inner loop is changing the value of n in every iteration from 20 to 10 to 5. And that is why, because n value is becoming smaller and smaller and smaller, iterations are very, very less. So this inner loop is anyways optimizing for non-prime numbers or composite numbers. Optimization has already taken place. But the problem for us is when n is a prime number. When n is a prime number, this inner loop is useless. It will never execute, because if you look at it, it will execute only once. It will execute only once. But if you look at this, for none of the values of I other than the number itself, this loop will execute, because none of them will be divisors, because a prime number will have only itself and 1 as a divisor, and 1 is non-prime, so it doesn't matter to us, which means only till 13. I hope you're able to think. So if at all any optimization must be done, the optimization must be done for this outer loop. For when in case n is prime, optimization should be done in this outer loop, where I don't want to go from 2 till n. If there was a way for me to quickly identify that, hey, this is a prime number and no need to go till here, my problem would have been solved. How, you may ask? The answer lies in this lecture, where I already spoke to you and I told you that if at all a number is a composite number, the first factor or the first divisor of that number will always appear on or before root n. On or before root n, you will find the first factor. I have already explained it there if it is a composite number. If you don't recollect, please go watch it. Which means, deriving from that logic, would I be able to say that, hey, listen, this is a composite number, isn't it? Do you see that the first factor has appeared before root n, and root of 40 is around some, how much, some 6 point something, and before root n itself, all the factors has arrived. Yeah, at least not all, at least the first factor has arrived. I hope you're able to think. If you look at a prime number, the only factor is the number itself, or n, which means n is 13. So root of this will be some 4, or 3 point something, round figure 3, let us keep. So 3, but you did not find a factor, see, it was not divisible, right? Which means if I go till root n and I realize that, hey, I still did not find a single factor, then I can immediately understand that this is a prime number, and I can exit out of the loop itself. I can exit out of the loop and just print the n value, which is the only factor. I hope you're able to think. But if it was composite number, this will anyways take care of it, and the moment n value becomes 1, you will exit. So this n greater than 1 will take care for composite numbers. But if it is a prime number, I don't want n till go till 13. From 2 till 13, I don't want to go. So what will you do, sir? This condition is the only thing you have to change. Because you can see this condition is the problem, where for a non-composite number, that is a prime number, it is going till n. But you can avoid going till n if you see whether a factor was found or not, a divisor was found or not before root n. So what I will do is, I will just change that condition and I will make it like this. I will just tell, hey, listen, check if I value, because I is what we are deciding is going to keep track of which are the factors. I will just check if the I value has reached root n or not. If it crosses root n, I will come out of the loop. It will anyways take care for composite numbers, prime number also it will take care. So see, I will tell I into I less than equal to n. And you know why I have written this, because if you apply square on both sides, it will become I square, here root will go. Any confusion till here? Now, if in case I do this, one thing you must understand. Now take a prime number only. Now prime number, I will become, first I is 2, 2 into 2 is 4. Is 4 less than equal to 13? Yes, condition is true. So you will go, while loop will anyways not execute, I will increment, right? 3 into 3 is 9. Obviously, when 9 is less than equal to root n or n value, which is 13, yes, right? 3 into 3 is 9, 9 is less than 13. Next time when you come to 4, 4 into 4 is 16, 16 will become more than that, which means only till here it will go. This is the false condition, control will come out. Now see, control has come out. Bring the cursor there. Control came out. Now if control comes out here, it means it is a prime number. If it is a prime number, I have to print it, because the prime number is the only factor, I have to print it. Now how will you print it? I'll just tell system.out.println and n I will tell, because the number only is the factor. But this line should execute only and only if in case it is a prime number. I hope you're able to think. Now how will you do that? Press enter. I'll apply a if condition. Now what should be this condition is the question. Just put the braces also. Now think about it, very easy it is. What this condition should be is, this condition is in a way you should be able to tell whether the number was prime or not. Sir, will you call is prime? No, all that is not required. See here, if in case it is a composite number, by the time you come out of this loop, n value would have become 1. Division. If in case it is a prime number, then at this stage you would have exited. At this stage when you exit, what is the value of n? 13. Is it 1? No. Is it greater than 1? Yes. Maybe I could have exited at this stage, I could have exited at this stage, some stage I would have exited depending upon the value of n. But my point is that n value will be greater than 1 if it is prime numbers. N will be 1 if in case it is a composite number. So I'll just go tell n greater than 1. How are you able to think? The moment n becomes greater than, if n is greater than 1 after coming out of the loop, 100% it is a prime number. Then only I will print this. Otherwise, if it is a composite number, anyways, printing would have taken care here itself. Really, will this work, sir? Definitely watch it. If in case I execute it, then I'll give composite 40. If I press enter correctly, 3 2s 1 5. 8 into 5 is 40. Next, if in case I execute, give a prime number, then only 13 it will print, right? But internally computer is very happy because optimization has happened. Now you must be wondering, what is the time complexity? Very easy. All of us know one thing, which is this particular loop is now going to execute only root n times. See, only till root n times it is going to go. So this outer loop is root n times it will execute. Now this inner loop is the question. Now this inner loop, look at it, very easy way to, you should have intuition to analyze time complexity. Always you should not sit and count. Every time the condition, how many times this will execute is determined by n, whether n is divisible or not by I. Every time n value is becoming half, or you cannot say half exactly, but it is getting divided, it is getting divided. So whenever one value gets divided into smaller pieces, always such a loop will work for log n times. Which means if this is root n, this is root n log n. I hope you're able to think, right? So I'm just showing outer loop, if it is root n, then the inner loop will be root n log n. Now which is the higher order term here? It is root n log n, which means, wouldn't you agree, you can eliminate this. This is only the time complexity, which means it is big O of root n log n. 100%. It is more efficient than the previous approach, which was big O of n, right? It used to go till n. So I hope how we did our optimization is clear to all of you. Anyways, I hope you enjoyed today's program, and make sure you guys are typing, practicing and revising, which is most important, and I will come back with an even better concept in the next class. Take care. Bye-bye.